Okay, well, so I will attempt to describe what all that means. And this should be fun for me, hopefully for you as well. I think my presentation will be from a slightly different perspective from some others presenting this evening. So I want to describe what designing for space means for everyone at Oblong. And to do that, I first want to start with a little bit of context. So back in the late 70s, if you were sitting in front of a computer, you would see something like this. It was the command line interface. It was basically a one-dimensional tool with a single line of text through which you could input commands to the system and get output. And then skipping ahead a few years, we come to something like this, and the advent of the graphical user interface, or the GUI. And with that and this contraption, we had a new way to refer to the space of the screen, and it took us into 2 dimensions. And fast forward 30 or so years, and here we are. And it's better, it's smaller, it's faster, and everything else. But for the most part, things haven't changed all that much. OK, so now a hard cut to the world of film. Cinema has been exploring new ways to create immersive and engaging and dimensional experiences for a variety of reasons. One, because they're more engaging for the viewers of the film. But also, they can be used to create narrative and push story forward. And when we talk about that type of thing, this is an off-cited example. Oh, we skipped past. Well, all right. We won't have a clip. Oh, there it is. We will have a clip. All right, so taking a look at this clip from Minority Report, there are a few things that I want to point out. First, there's a lot going on, but of note, there's lots of information in this space, and that information is situated all around the lead protagonist, who is interacting with the virtual content in this world through a variety of gestures and hand poses. Fittingly, Minority Report, Alex McDowell, the person who coined the term immersive design, was the production designer on this film. But now a quick cutaway to something else important. Just before that film came out, John Underkoffler, the CEO and chief scientist of Oblong, was working at the MIT Media Lab in the Tangible Media Group on something called the Luminous Room, pictured here. And that was exploring ways to take the interface of the computer and pull it outside of the screen and into the physical realm. OK, so now cut back. There we go. OK, so he was brought on as science advisor for the film Minority Report and worked with Alex McDowell and others to define a gestural language for the actors in that film. And this was really important because creating really believable gestures was important to allow the sequences of the film to actually drive the narrative forward. And so this is the lexicon that was given to the actors to study so that they understood the way that they were interacting with the world around them, even when all of the things in the final sequences you saw in the film weren't actually present while they were performing those gestures. OK, fast forward a little bit more. Here's Oblong. Oblong was founded in 2006, and with a goal of bringing those types of interfaces and experiences into the real world and defining a new way to interact with the future of computers. So in the early days, we have things like this. There was a lot of emphasis on gesture and hand pose. Here's another example. This is Tamper, which premiered at Sundance in 2009, which was a multi-hand gestural system for live cutting and compositing film sequences. And this was a collaboration with Jer Thorpe more recently, which is a visualization of all of the exoplanets called Kepler. And you can see while looking at these that all of them are gestural, but there was something else tying them together that we thought was actually more fundamental to what was going on here. You may note that most of them, in fact, all of the ones that I'm showing you now, have multiple screens, and in most cases, those screens are situated in non-coplanar arrangements. So that became really important for us, as well as a way to point at things on those screens, because humans have an innate ability to reason about space around them. And when you point at something, you understand, and so does everyone else in the room, exactly what you're referring to. And so that became the basis for our platform. So I want to talk a little bit more briefly about how that platform works, and then show you some of the stuff we've built with it. So here's a room, and there's a screen in the room. And that screen traditionally has some kind of origin, probably in the upper left, maybe lower left, doesn't really matter. It's 0, 0, and it defines an XY plane on which all of the user interface elements are arranged. So what happens when you add a second screen? Maybe on a different wall. So that's fine, but OK. And they've each got their own origin, but they don't have any way to talk about where they are relative to each other. So now what? So the key idea behind the software that Oblong builds is that there's a shared 3D origin that is in the space of the room, and then we can define the position of any screens in that room relative to that origin. And perhaps even more importantly, we can define the relative positions of those screens with respect to each other. We can also talk about points that don't actually lie in the bounds of the screens. We can talk about points that are outside, or we could get rid of the screen entirely and just talk about a point on the wall. Maybe, for instance, to turn the entire wall into a button or an interactive element. OK, and so on the spectrum of spatial relationships, at the far left, the lowest fidelity, we have topology and proximity. We're all in this room. That gives us something in common, but doesn't tell us a whole lot. I might be able to look at you and say, oh, you're to my right or to my left. So that's relative positions. So we know a little bit more about where things are with respect to each other. But at the far right, we have true absolute positions of objects where we can say precisely where we are, how many millimeters apart. And that's where things get really exciting for interaction with these spaces. And the key to unlocking that potential is the ability to use space as an input and track 6 degrees of freedom for pointing both orientation and position in 3 dimensions. So what does this look like when you put it all together? Here's a quick little earthquake visualization program that's written in Greenhouse, which is an extension of the GSpeak platform that Oblong builds. And in this example, there are 3 screens sort of surrounding the viewer. And you can see that from this perspective, all of those screens are able to immerse the viewer on 3 sides with a shared view of the universe. And something else that's important to us is the ability to scale this up. And in this example, I can get it to play. OK. In this example, there are 5 screens in the room. There's a Mac laptop, and there's a couple of Ubuntu towers, collectively driving 5 screens. And the same application is running across all of those screens seamlessly. And so naturally, this could scale up to an arbitrary number of devices. And we think that's really important for the future of these kinds of interactions, that you could have experiences span any device in the room. Here's another quick example, which illustrates that you can also take advantage of the size and known position of these types of devices to display slightly different content that suits your needs. Whoa. OK. So now I want to take a moment to talk a little bit about mezzanine and bring all of those types of ideas into one room. So this is the closest thing you'll see to the Minority Report future we looked at before. It's not quite the same, obviously, but there are commonalities. In particular, there's an awful lot of pixels in this space. There's a bunch on the front wall. There are more on the side walls, non-coplanar. There's a whiteboard to the left. That's also an active addressable space in the room that can be interacted with. And there's a telepresence unit and a tracking system. And so you put all these things together, and you turn a conference room into a much more engaging space for a collection of people to work collaboratively. So any number of people can come into one of these rooms. There are active pixels all around them, so they're completely engaged in the space. They can bring their own devices, be it an iPad or a laptop or a phone. And all of those also have applications which integrate with the space. There's a whiteboard, which you can point at and capture to bring the analog into the digital world. And of course, you can grab all of these elements with these spatial tracking wands and move them to other surfaces in the room, as well as reach through various things presented on those surfaces to interact more deeply. So that's a quick peek at how we've taken this spatial computing platform and built something that we think is really exciting because it gives people a new way to interact and engage with each other in a democratic fashion. And while on the one hand, this is sort of the culmination of everything we've built so far at Oblong, we also view it as a first step in these sorts of spatially aware, immersive application experiences. That's all.